Let's solve the solved examples, or let's try to understand the solved example 5. Here, a quadrilateral ABCD is given, whose points ABCD intersect at point Q. 2QA is equal to QC. What's the given condition? 2QA is equal to QC. And the next condition is 2QB equal to QD. And we have to prove that DC is equal to 2AB. Now which sides? 2QA. QA is here. Twice of QA is equal to the measurement of QC. That means what? QA is half of QC. Twice means what? If QA is 5, then QC will be how much? Twice of QA, right? It's given twice of QA is equal to QC. So 2 into 5 will become 10. So the value of QC will be what? Will be 10, right? So what is the relation of you write the values QA upon QC? If you want to find the ratio of QA upon QC, you will write the values and see. QA is 5. QC is what? QC is 10. 5 ones are 5. 5 twos are 10. So relation is 1 upon 2. This is one way of doing it. Or we can cross multiply and bring QC this side. 2QA equal to QC. And when we cross multiply and bring it here, cross multiply only the alphabets, then it will come QA upon QC. Okay, and then when you want to bring it to this side, this is multiplication 2 into QA. When you want to bring it to the right hand side, it will come below, it will come here, 1 upon 2. It will become 1 upon 2. So you have QA upon QC is equal to 1 upon 2. Same way, same thing, 2QB is equal to QD, same, 2Q is equal to QC, the ratio is also QB upon QD, ratio is 1 upon 2, same thing, like, here if you take QB as 5, or suppose I take it as 2, then QD will be 4, that is twice of QB. So QB upon QD is also half, okay. So what are the ratios we have got? We have got QA upon QC, which is equal to half, first equation. Second equation is QB upon QD, also equal to half. You can see that the right hand side both are half, therefore left hand side will be equal, that is QA upon QC is equal to QB, or the ratio, it is a ratio, though I am saying upon, it is the ratio. Ratio of QA upon QC is equal to QB upon QD. Okay, because both the ratios, the value, right hand side value is half. Now we will take this triangle BQA and triangle CQD. Now which sides we have found in proportion? We have found that third one. QA upon QC, QA is to QC is equal to QB is to QD. That means the corresponding sides are equal. Okay, for similar triangles, we have said that the corresponding side should be similar. So it is similar, the ratio is similar. Both these ratios are similar because the value is half. Now this angle, okay, what is this angle known as? Okay, if you have two lines intersecting, okay, this line is say BD and this is CA and it is intersecting at point Q. Now when two lines intersect, this point which forms an angle, these angles are known as vertically opposite angles and they are congruent. So which angles are congruent? Angle BQA is congruent to angle CQD. Why? Because they are vertically opposite angles. Opposite angles, okay? Now these two triangles, which triangles we have taken? Triangle BQA and is similar to triangle CQD by which test? SAS test of similarity. Why SAS and SAS? Because two sides are in proportion. Two sides in proportion, right? QS to QC is equal to QB is to QD. Two sides are proportion, and in between those two sides you have an angle congruent. So SAS test of similarity, we have learned that two sides, corresponding sides are in proportion and the angle included in it are congruent, and those two triangles are congruent by, not congruent, is similar by SAS test of similarity. Now when the triangles are similar, the corresponding sides will also be similar. So what is the remaining side which is remaining now? The third side which is remaining, we have taken this and this, that is QB and QD, and then we have taken QA and QC. So remaining is this one. So BA is upon CD or DC. Okay, B upon CD. Now what we have said, that they all are equal, right? So BA upon CD will also be, the ratio will also be half because they all are in proportion. Okay, so B upon CD is okay. Then what we do, we cross multiply, and when we write 2, when you cross multiply, you get 2BA or 2AB, which is equal to CD or DC. This is what we had to prove. Understood? First, what we found? We found that the ratios to QA is equal to QC. The ratio is 1 upon 2. Second one, 2QB is to QD. The ratio is 1 upon 2. Then we found that since the ratios of both are equal half, therefore QA upon QC is equal to QB upon QD. Then the angle included in between two sides are congruent. Why they were congruent? Because they are vertically opposite angles. Therefore, those two triangles, triangle BQA is similar to triangle CQD, which is because of SAS, test of similarity. When the triangles are congruent, the corresponding sides are in proportion. So, what are the remaining sides which will be in proportion? BA is to CD. And what will be the same proportion? Because all will be equal. So, therefore, its proportion will also be half. And when we cross multiply it, we got 2A AB is equal to DC. Now, we'll do the steps. Okay, 2QA is equal to QC, given condition. Therefore, when you cross multiply, you get QA upon QC is equal to half. Second condition was 2QB is equal to QD. When you cross multiply, you get QB upon QD is equal to half. And from 1 and 2, you found that the right hand side both are half. Therefore, the left hand side, that is QA upon QC is equal to QB upon QD. What is the point you have to remember? A is equal to B and C is equal to B. Therefore, A is equal to C. Now, which is A? This is A. QA upon QC is A. Half is B. Here also half is B, and this is C. And therefore, which are congruent? QA upon QC is equal to QB upon QD. Then, in triangle AQB and triangle CQD, this is the triangle, a part of it. This part, I have drawn it separately. Which sides are proportion? QA is to QC is equal to QB is to QD. We have proved it. And angle AQB, this angle AQB is congruent to angle DQC. Why they are? Because they are opposite angles. And therefore, triangle AQB is congruent to triangle CQD. These two triangles are congruent. they're not congruent, they're similar. Okay, they're similar to SA because of SAS test of similarity. Now, when the triangle is similar, automatically the remaining sides will be equal. So QA upon QC is equal to QB upon QD, which is equal to corresponding remaining side AB upon CD. This side AB upon CD. Corresponding sides are proportional. Now we found that QA upon QC is half. We know that QB upon QD is also half. And since QA upon QC and everything is equal, therefore the value of AB upon CD is equal to half. From above, from 1 and 2 we have got that it is half, and then from 1, 2 and 3 we have got it that AB upon CD is half. Then when you cross multiply, you get 2AB equal to CD. The right hand side, just read this what are vertically opposite angles. Vertically opposite angles are angles that are opposite one another at a specific vertex and are created by two straight intersecting lines. The straight intersecting lines, here the figure is here, and vertically opposite angles are equal to each other. Using this vertically opposite angles, we got this angle AQB congruent to angle DQC. So we have proved 2AB is equal to CD. Thank you, dear children, and God bless you always.